Okay, in question 1 here, we're dealing with probability. The first part of the question had 10 marks, the second part had 5 marks, and the third part had 10 marks. In the first question, we're told that there's 2 problems, and that 45% of people solved problem number 1, 25% of people solved both problems. What is the probability that someone solved problem number 2 given that they solved problem number 1? You should realize that when they use the word given, that's a hint that it's conditional probability. What is the probability they solved problem 2 on the condition that they solved problem 1? So, if you use your conditional probability formula, the probability of 2 given 1 is the probability of 2 intersection 1 divided by the probability of 1. 2 intersection 1 is the people who solved both of them, so that's 0.25. Probability the proportion who solved 1 is 0.45, so it's just 0.25 divided by 0.45. So the probability that someone solved problem 2, given that they solved problem 1, is just 5 over 9. Okay, in B part 1, we're talking about a water pump. The probability that a water pump is faulty is 0.04, so by extension the probability it's not faulty is 0.96. And we're told that if we take 12 of these water pumps off the production line, what is the probability that only one of them will be faulty? So you should realize this is a Bernoulli trial. I'm going to take 12 pumps off the line, and one of the 12 will be faulty, but I don't know which one. So it's a combination. I don't know the order, which means I have to do a Bernoulli trial. Success is 0.04, failure is 0.96, the number of trials is 12, and the number of successes is 1. So it's 12, choose 1. One of them is going to be faulty, 11 of them are going to be not faulty, so if you just plug that into your calculator, you get 0.31. It asks me to leave it to 2 decimal places, so you get the 5 marks for 0.31. Okay, the final part of this question carries 10 marks. And it asks me, what is the probability that of the 12 pumps, no more than 3 of them are faulty? If no more than 3 of them are faulty, then there's 4 acceptable scenarios. Either that means none of them are faulty, 1 of them is faulty, 2 of them are faulty, or 3 of them are faulty. So I just need to do 4 different Bernoulli trials and add them all together. So if 0 are faulty, it's 12, choose 0, success to the power 0, failure to the power 12. The next one is 12, choose 1, success to the power 1, failure to the power 11, success to the power 2, failure to the power 10, and so on. You do it 4 times, and you have to be very careful with your numbers here. So I've gone to a few decimal places in each case. When you add them all together, you get 0.999, which is not quite 1. So in other words, like if I turn that into a percentage, that would be 99.9%. So either of those answers are acceptable. It said to leave it to 2 decimal places, so you could either leave it as 0.99 or 99.90%, which is not quite 1. A lot of people got confused and they thought their answer was working out as 1. Look how unlikely it is that one of them is faulty. There's only a 4% chance that one of them is faulty. So it's fairly likely that no more than 3 of them out of 12 will be faulty. So it's a 99.9% chance. Okay, in question 2, the marks are split up the same way again. 10 marks, 5 marks, 10 marks. The first part of the question, you're given the equation of a circle and you're asked to find its center and find its radius. The first thing you should do is bring your 21 across just so it's in the right form, so you have everything in this way. Now, to get the center, you need to look at the number in front of x and the number in front of y. Whatever's in front of x is 2g. And to get the center, you need minus g and minus f. So if you take whatever's in front of the x and divide it by minus 2, minus 10 divided by minus 2 gives you plus 5. So the x value of your center is 5. If you take the value in front of y, which is minus 8, divided by minus 2, the y value works out as 4. So the center of your circle is 5, 4. Then to get the radius, again, it's straight from my log tables. It's the square root of g squared plus f squared minus c. G is half the coefficient of x, so it's minus 5. Y is half f is half the coefficient of y, which is minus 4. And minus c is minus whatever this number is, so it becomes minus 21. You plug it into your calculator, and your radius is 2 root 5. Okay, the next part of the question, I need to find the equation of a line that goes through the point 3 minus 2. So to get the equation of a line, I just sub into this formula from my log tables. If you sub it in, instead of y1, you put in minus 2. Instead of x1, you put in minus 3. You just simplify it down, and you get to the answer they were looking for, and there was 5 marks for that as well. The final part of this question says, hence or otherwise, find the equation of the two tangents that go from the point 3 minus 2 and are tangents to the circle. So I know that the equation of every line through the point 3 minus 2 is that it can be written in this form, and it just depends on what the slope is. So your best bet is you can draw a diagram like this. The center of your circle is 5, 4. You know the radius is 2 root 5. And you know the equation of the tangent, the generic form for the equation of the tangent and that tangent is mx minus y minus 3m plus 2. So you should realize that this is a perpendicular distance formula, because at the point of contact, the radius and the tangent are perpendicular to each other. So you know the perpendicular distance from the center of the circle to the tangent is the radius. And I know the radius is 2 root 5. So if I use my perpendicular distance formula, I can let it equal to 2 root 5. The perpendicular distance from 5, 4 to that line is 2 root 5. So if you sum into your perpendicular distance formula, a will be the number in front of x, which is m, b is the number in front of y, which is minus 1, c is the number on its own, which is minus 3m minus 2, x1 is 5, y1 is 4, and the answer is 2 root 5. So if I just sum into this, the only thing I don't know is m, and I'll be able to get two different values for the slopes. The slope of that line and the slope of that line. So like we said, this is my a, b, c, x1 and y1. I sub into my perpendicular distance formula and I can let it equal to 2 root 5. If you simplify out the top, you end up with 2m minus 6 on top. And at this point, your immediate complication is your fraction. So you can multiply both sides by the denominator and you end up with a root m squared plus 1 on the right hand side. In order to get rid of these modulus signs and in order to get rid of these surds, you're going to square both sides. When you square both sides, remember you have to actually square 2m minus 6. A big mistake was a lot of people thought that the squared and the modulus will cancel each other out. You have to actually multiply 2m minus 6 by 2m minus 6. You get 4m squared minus 24m plus 36. On the right hand side, 2 root 5 squared is 20. And root m squared plus 1 squared is just m squared plus 1. So if I multiply it out, at this stage I have an m squared, an m, and a number. So I'm just going to bring everything to one side, factorize, and find the values of m. Okay, so all I've done here is I've brought everything to the right hand side, and I get 16m squared plus 24m minus 16. Obviously, I don't want to factorize it like that, so I divided everything by 8, and it became a lot more simple. If you factorize it and solve, you get the slopes are a half or the slopes are minus 2. Once you have your slopes, you can sub back into the generic formula for the equation of the line. We said that any line that goes through the point 3 minus 2 can be written as mx minus y minus 3 times 3m plus, minus times 3m plus 2. So you just sub in your slope. In one scenario, you sub in the slope equals a half, and it works out like this. In the other scenario, you sub in the slope equals minus 2 and it works out like that. So your 10 marks are going for those two equations. Okay, for question 3 part A here, we're given a triangle. They've referred to it as a polygon. It just means like a random shape. And we've been given the line E, F, and D that make up a triangle. And we've been told to use the formula tan theta equals plus or minus m1 minus m2 over 1 plus m1 m2 in order to figure out the nature of this triangle. So obviously they've given me enough information from the diagram that I can tell what the slopes are. I can use the slopes and find the angles. So this question means find the 3 angles in the triangle and then identify, hopefully you'll recognize a trend when you have it. So the easiest way to get the slope in each case is to use the rise over the run. You could use y2 minus y1 over x2 minus x1, but it's a lot quicker to use your rise over run. For the slope of E, it works out as minus 4 over 7. For the slope of F, it works out as a half. And for the slope of D, it works out as 8 over 1. So they're the 3 slopes that we're going to use for the rest of the question. Now I need to use this formula 3 times and find the 3 angles in the triangle. Okay, so the first angle I'm trying to find here is the angle BAC. If I'm trying to find the angle BAC, that means I'm trying to find the angle between the lines E and D, which means the slopes I'm using are minus 4 over 7 and 8. Now, if you're subbing into this formula and you're looking for a slope, you can more or less ignore the plus or minus. If your answer is ending up positive, well, think about this. Clearly, the angles that you want, the 3 angles you're going to get, are all going to be in the first quadrant. You can tell that none of those are bigger than 90 degrees. And I know that the tan of an angle is positive in the first quadrant. So when I get the tan of whatever it is, I'm going to take the positive value, so that my answer is between 0 and 90 degrees. If you take a negative value, if you end up with a minus in front of it, you just ignore it and you take the positive one. Because the tan is negative in the second quadrant. So a negative tan, you'd get an angle bigger than 90. And clearly from your diagram, none of your angles are bigger than 90 degrees. So you can more or less ignore the plus or minus. You sub in your M1, your M2, and it works out as 12 over 5. Tan inverse of that, the first angle is 67.38. Now we just need to find the other two angles. The second angle I'm calculating here is the angle ACB. In order to get the angle ACB, I need the slope of the line E and the slope of the line F, which is minus 4 over 7 and a half. If you just plug that into your formula, it works out as minus 3 over 2. Notice again, I've more or less ignored my plus or minus. It ended up as minus 3 over 2. Well, I know if the tan of an angle is negative, that's not in the first quadrant, that's second quadrant. So I just ignored the negative and made it a positive. I'm actually saying tan theta is 3 over 2, so I get tan inverse of 3 over 2. So the angle ACB must be 56.31 degrees. Now we've got one more angle in our triangle to find, the angle ABC. Okay, to get our third angle, the angle ABC, one of my slopes is 8, the other one is a half. If you plug it in, you get tan theta is 3 over 2, so tan inverse of that is 56.31 degrees. So now the three angles I've worked out is one of them is 67.38 and two of them are 56.31. So I could say that angle ABC is equal to the angle ACB because they're both 56.31 degrees. So obviously this is an isosceles triangle. So the nature of the polygon they're looking for there is that it's an isosceles triangle. Okay, probably the easiest way to do part B to get the area of the triangle ABC is to use the formula from your log tables, a half times the absolute value of x1, y2 minus y1, x2. In order to use that formula, you need to have a triangle OPQ. In other words, one of your coordinates needs to be the origin. So we need to do a translation to move this triangle so that one of the coordinates is at the origin. The coordinate I've decided to translate to the origin is B. So in order to move B to the origin, all you have to do is subtract 2 from your x. Nothing happens to the y, you just subtract 2 from the x. And that would allow me to move B over to the origin. If I move B over to the origin, I have to move A the same distance and C the same distance as well, so that the area of the translated triangle is the same as the area of the original triangle. So whatever I did to B, I'm also going to do it to A and I'm going to do it to C. So in order to go from B to the origin, I subtracted 2 from the x. So that's what I'm going to do with this C. Instead of a 10, it becomes an 8. And that's what I'm going to do with the A. That's instead of a 3, it becomes a 1. So now I'm going to get the area of this translated triangle, where this will be my x1, y1, this will be my x2, y2. All I have to do is sub into this and get the area. Okay, so when I sub in here, I'm subbing in x1, y1, x2, y2, and I ended up with a minus 60 in my modulus. The only reason I ended up with a minus 60 in my modulus is just the way that I assign these. If I had assigned them the other way around, if I had assigned this is my x1, y1, that is my x2, y2, I would have ended up with a plus 60. But this doesn't matter, it's because whatever's in the modulus signs, we always take it as positive. So instead of taking that as a minus 60, I just take it as a plus 60. A half by 60 give me 30 units. So the area of that triangle, there was 10 marks going for it, is 30 units. Okay, so for the first part of question 4, the first 2 parts is just your learning work. If you didn't get it right, you need to sit down and learn it. There was 10 marks for the first proof, 5 marks for the second proof, and then 10 marks for this unit circle bit. So in the last part it said cos 3 theta is root 3 over 2. And it asks you for all the values of theta between 0 and 360. But you should realize that the 3 here is the most important bit. If there's a number in front of the angle, the very first thing you should do is triple your domain. Rather than looking for theta between 0 and 360, you're going to look for 3 theta between 0 and 1080. And so to get your reference angle, you can read it off your log tables, or you can get cos inverse root 3 over 2, and it works out as 30 degrees. Cos is positive in the first quadrant and the fourth quadrant. To get a value in the first quadrant is just 0 plus your reference angle, so the first one is 30. To get a value in the fourth quadrant is 360 minus your reference angle, so it's 330. Now there's a load of different ways of getting the next few, you could continue on and say the second time you go around is 360 plus and then 720 minus. That'll give you your next two. You can go around again and say that it's 720 plus or 1080 minus. Or if you get the first two, you can just add 360 to both of those and get these two. Add 360 to both of those and get these two. That works out your 6 different answers. You get 3 theta is equal to these 6 answers. But obviously you don't want 3 theta. You want theta. So if you have 3 theta, in order to get theta on its own, you just divide everything by 3, and your answers are 10, 110, 130, 230, 250, and 350. Okay, so for question 5 here, there's 15 marks for the first bit, there's 10 marks for the second bit. In this question, we're told that the mean lifetime of bulbs that a company makes is 1,500 hours. That is, they didn't say that they took a sample and that the mean was 1,500 hours. They just said that the mean of their bulbs is 1,500 hours. That implies that it's a population mean. That's all of the bulbs they've ever made. That is mu. That's the population mean. The average of all of their bulbs is 1,500 hours. So now they're just investigating if that's still true. So they took a sample of 100 bulbs that had a mean of 1475. That's your sample mean. And the standard deviation was 110. Now, it could be a coincidence that the bulbs that you took were less than the average. Maybe you just took a dodgy batch of bulbs. Now we need to test, is there a statistically significant difference between those two figures? To the point where I can say, well, actually the mean of all the bulbs isn't 1,500 anymore because these bulbs were so much lower, there's no way that it was a coincidence. So it says test the hypothesis at a 5% level of significance, which obviously means you have to do your HO and your HA. Now in the leave insert, you'll get the marks for whether you do a one sample Z test or a confidence interval. But for anyone who did a confidence interval, you should be doing it like this. Statistically, this is the way that they do it. You'll get the marks, and if you look back in the marking schemes from previous year, you get the marks for either a confidence interval or for this, but I advise you to do this one, especially for a question like this, where part B asks you to do a p-value, because you're going to have to work this figure out anyway. So it makes your life a lot easier if you use the one sample Z test. So the formula for your one sample Z test is here. It's the sample mean minus the population divided by the standard error. So you're comparing 1475 to 1500 and you're dividing it by the variability. Let's just look at our null hypothesis and our alternative hypothesis. The null is that the mean lifetime of bulbs has not changed, while the alternative is that the mean lifetime of bulbs has changed. You just plug in your values and your z-score works out as minus 2.27. Now, we need to conclude these by 3 different methods, purely because they're changing their mind with the marking schemes each year as to what they actually require. So now we have 3 different things we need to do to conclude. Okay, so the 3 conclusions you should make are graphical, mathematical, and then explain it in the context of the question. Graphically, you draw yourself a normal curve, you mark 1.96 and minus 1.96. If your z had been in there, you would have failed to reject HO. If your z is out here or it's out here, you're going to reject HO, and you should indicate where your z-score, this is your z-score, is minus 2.27. Graphically, that explains that you're rejecting. Mathematically, you should say that your z-score is less than minus 1.96, therefore you're going to reject HO. And then you should say, well, if I'm rejecting HO, you reiterate the alternative hypothesis. The mean lifetime of bulbs has changed. So there's 15 marks going for that bit, and now we need to use this diagram in order to get our p-value. Okay, so to get our p-value, the p-value refers to the percentage of figures that are more extreme than your result, more extreme than your z-score. Our z-score was minus 2.27. And I need the percentage of figures that are below that or above the corresponding positive one. The percentage of figures that are greater than or further away from the mean than 2.27. So in order to do that, in order to find this section, that's the probability z is less than minus 2.27. You can't read negative z-score off your log tables, so that's the same as the probability z is greater than 2.27. In other words, this section and that section are the same thing. I can't read a greater than off my log tables, so that's the same as 1 minus less than. 1 minus the probability z is less than 2.27. I can read that off my log tables. It's 0.9884. So 1 minus that is 0.0116. So the proportion of figures in there is 0.0116. but I need both regions. This is what's called a two-tailed test, so I need to multiply that by 2. My p-value is 0.0232. I want you to be aware, if they ask you for critical region or critical value, it's the same thing. Once you've got your p-value, I have my explanation here. My explanation of this is you have to refer to the fact that p is less than 0.05, or you would do the opposite and refer to the fact that it's greater than 0.05, but you have to refer to the 5%. So because it's less than 0.05, I can say that less than 5% of the data is more extreme than our result. I.e., our result is outside the 5% significance level, so we're going to reject HO. So there was 10 marks going for that bit as well. Okay, so for question 6, again, I'm not going through the theorem. There was 15 marks for your theorem, 5 marks for the first part of B, 5 marks for the second part of B. The first part of B, it asks me to prove that the triangle ABD and the triangle EFD are similar. Similar triangles are triangles that have all equal angles and their sides are proportional. In order to prove the two triangles are similar, we have to be able to prove they have 2 sets of equal angles. If they have 2 sets of equal angles, the third set is obviously the same because the 3 have to add up to 180 anyway. So once I can prove that 2 of these angles are equal, we can assume that the third set of angles are also equal. So the first one I can say is that the angle at B and the angle at F are equal to each other because they're both right angles. Then I can say that the angle at D and the angle at D are equal to each other because it's a common angle. That's 2 sets of angles. That's enough for that I can say that the triangle ABD and the triangle EFD are similar. And that's your 5 marks for that one. Okay, question 7 here was the nicest question on the paper. There's 60 marks going for this one, and it seems like people are either getting full marks or just none at all. So I want to just go through with you what you need to look at when you're getting one of these questions. If you get a trig question, now it told you it's a sinusoidal graph. That does not mean it's a sine graph. That means that it's either a sine graph or a cos graph. Sinusoidal graphs are just the ones that oscillate, doesn't necessarily mean it's sine. When you're reading this question, the only pieces of information you need to figure out what is the top, what is the bottom, and what is the frequency. What's the period, what's the range. If you can identify those 3 pieces of information, you'll be able to get 60 marks out of 60 in this question. It says you're hopping into this Ferris wheel, and each one is 2 meters above the ground. So the minimum height you're going to be at on this Ferris wheel is 2 meters. The radius is 22 meters. So obviously the radius is 22 meters, so the diameter must be 44 meters. So if this is 2, I add on 44, the highest point I'm going to get to is 46 meters. And if that's a 2 and that's a 46, 2 plus 22 gives me 24, plus 22 gives me 46. So I know the minimum, I know the maximum, and I know the midline. It told you that when you get in, so we're clearly getting in at the bottom here, you're getting in at 2 meters and you're going to go up to the top and then back down to the bottom. It told you that after 3 minutes, you'll be at the top. So it takes 3 minutes to get to the top, which obviously means it takes 6 minutes to go from the bottom to the top and back to the bottom. So you know that the period of this graph is 6 minutes. If you get a trig graph, these are the only pieces of information you need to figure out from whatever the question is. Now that I know 2, 46, and 6, I can answer the whole question. The first question asked me to find the equation of the midline. So clearly the midline is 24. And you know the equation of any horizontal line is y equals whatever the y value is. So the equation of the horizontal line is y equals 24. That's the answer to part A. The answer to part B, it asked me what is the range. The range here, the minimum is going to be 2 meters, the maximum is going to be 46 meters. So the range there is from 2 meters to 46 meters. Part C asked you to find the period. So the period in that case is 6 minutes. It takes 3 minutes to get to the top, 3 minutes to get back down, so the period is 6 minutes. Although they did accept in that case if you worked out your C. You could give the answer as 6 minutes, which technically is what you should have given, but you get the marks. You know C is 2 pi divided by the period. So if you had done that and said your answer was 2 pi divided by 6, which is pi over 3, you get the marks for that either. So they were accepting your period is 6 minutes, or they were actually accepting pi over 3 as well. So just notice there, the first 3 parts of that question were a breeze once we had this, the first 3 parts were very straightforward. 5 marks are going for that bit, 5 marks for that bit, 5 marks for that bit. Okay, for question 7 part D then, we have to figure out, is it a sine graph or is it a cosine graph? Joan said it's a cosine graph, so you should agree with Joan. And I've just taken this directly from the marking scheme. That's what it says there. The loading platform is not on the midline, so therefore it's a cosine graph. Basically, any reference to the midline there will get you your marks. If it was a sine graph, it would be starting at the midline and going like that or going like that. Clearly, that's not what's happening here. In this case, we've already sketched it. We're starting at the bottom. We're going up, down, up, down. So if you're starting at the bottom, it must be a minus cos graph. We can use that now to answer the next part of the question, part E. Okay, so again, notice those, at the start of the question, we identified 3 pieces of information. The minimum, the maximum, the period. Now we're still, every mark we've gotten so far has just been based off of that, and we're still going to get that in part E. In part E, you should recognize that you're starting at the bottom, which means it's the 4th diagram, it's a minus cos graph, and now you're asked to write this function f of t. So you need to remember that A is your midline. We've already identified our midline as 24. And B is the amplitude. We've already identified the amplitude as 22. So it's minus, we're putting a minus in there because it starts at the bottom. And then C, I already referred to it. In order to get C, that is 2 pi divided by the period, which in this case is just 2 pi divided by 6, which in this case is pi over 3. So in that case, you get pi over 3 times t. And that's your final answer for that bit. You needed to specify that you're using part 4, and then 24, 22, and pi over 3. Okay, in part F now there's 10 marks. There was 10 marks for part D, 15 marks for part E, and now 10 marks for part F. I'm asked to draw the graph for 1 rotation. And now, obviously mine is a bit rough because I'm doing it on a glass board, but yours needs to be as accurate as possible. You don't need to write in the midline. You're not required to write in the midline, you're just required to draw the actual curve. The points I would suggest you mark in are these ones. The coordinates 0, 2. I know that when t equals 0, I'm getting in. You also know that after 3 minutes, you're at the max height, so 346, which obviously means that you're at the midline halfway between 0 and 3, which is 1.5. So I would have plotted the point 1.524, also plot the point 4.524, and then 6, 2. Now you can sub in as many values as you want there, because in the previous part of the question we have the actual formula. So you could sub in and be more accurate, but you'll get the full marks, you'll get your 10 marks for plotting those points and drawing your graph. For part G, there's 10 marks going for us. They asked you what height will you be after 2 minutes. After 2 minutes, you sub into your formula. Remember, that's pi over 3, so that's in radians. So make sure you convert your calculator into radians. You plug that in, and you work out that after 2 minutes, your height is 35 meters. Okay, so for question 8, the first part of this question asks me to come up with a sampling method that daft.ie could use to get the average rent in Cork. Now, it actually says in the marking scheme that you can use any sampling method. You can write down any sampling method with a correct explanation. So if you're given that option in the exam, I think you should go with stratified random sampling. Strata refers to groups or layers. So to explain it, I said you could divide Cork into different areas. Take a simple random sample of each area proportional to the number of people renting in that area. So I'm taking a simple random sample from each area in Cork. But if one of the areas has way more people renting than another area, I need to take a larger sample. So the size of the sample from each area is proportional to the number of people renting in that area. If I was correct in that, that's the word I'm looking for. If you're explaining stratified random sampling, you should be using the word proportional. That each sample size is proportional to the size of that area or that group. Okay, for part B here, there was 15 marks. You can calculate the mean using your calculator. You can calculate the standard deviation using your calculator. We have both of those classes. If you weren't 100% sure on that, there's 2 free classes on that on Friday. Make sure you make it to one of those. Or you can even just look it up yourself. Make sure you know how to get your mean, get your standard deviation, because we need to use those figures now to do the rest of the question. Okay, for part C here, it says previous year's statistics have shown that the rents across Dublin are normally distributed from your calculations to B part 1 and B part 2, i.e. the sample mean and the standard deviation. What is the range of rents you would expect to find 95% of the 2-bedroom apartments in the areas to lie between? So a lot of you went for the empirical rule here. The empirical rule is on the ordinary level course as well, and it's a rough estimate that roughly 95% of figures are within 2 standard deviations of the mean in a normal distribution. But that's an estimate. At higher level, you're only allowed to use it if they tell you to use the empirical formula. So in this case, they didn't mention empirical rules, so you're not allowed to use it. To accurately come up with the 95%, they're actually referring to the confidence interval. You need to come up with a 95% confidence interval. So the mu, the population mean in this case, would be the result of your sample plus 1.96 times the standard deviation over root n. That's the upper limit. The lower limit is the result of your sample minus 1.96 times sigma over the square root of n. So remember, I know I'm using sigma over the square root of n and not the proportion because this is numerical data. It's numerical data, and especially because you have a standard deviation. If you have a standard deviation, it's clearly you're dealing with proportion. So in this case, the result of my sample was this, and the margin of error, the degree to which I could be wrong is that. So you add on 108.511, you subtract 108.511, and you can be 95% confident that the actual, if you actually worked out mu, it would lie between this figure and this figure. So that's what the marks we're going for in that question. Okay, so part D. Choose 6 areas from the tables and display the 2014 and 2015 rent. Display means draw a graph. The only way you can display something is to do a graph. Probably your best bet is something like a bar chart. Now I'm going to run out of space, so I've only chosen 2 different areas, Balbriggan and Blackrock. But obviously you needed to choose 6 areas. It says, what observation can you make about the rents between the years? Comment on any trends you notice in the price of the rents. So you have to do a display, means you have to do a graph. In this case, I've said, right, if I shade it in, that represents 2014. If I have a clear box, that represents 2015. So for Balbriggan, I've shaded in, it's 754, but the clear one is 821. For Blackrock, it was 1232, but now it's 1420. So clearly in both of those cases, the rent has increased. You obviously needed to do that 6 times, and in each case it would have increased. So then your observation can be that the rent increased from 2014 to 2015. Okay, in part E, I'm given the rents from 2014 and 2015 compared on a trend graph. And does this graph support your claim in part D? My claim in part D was that the rents have increased from 2014 to 2015. So I could say that yes, it clearly shows that the rents in 2015 were higher than in 2014. So I'm kind of just reiterating what I said in part D, but this graph agrees with my graph. In the final part of this question, we're told that it's claimed the average rent for a 2-bedroom apartment in 2015 was $994 per month. That's a claim. That's a population mean. The average rent of all of them in Dublin was $994. That's not a sample, it's a population mean. The estate agent conducted a survey of 50 such properties, so N is equal to 50. The sample had a mean rent of 1,050, so the sample mean of my 50 was 1,050. That's X bar, and the standard deviation was 390. So I know N, X bar, and sigma. It says using the estate agent sample, conduct a 95% confidence interval for the mean monthly rent of a 2-bedroom apartment in Dublin. Now, so you don't actually need mu at all. We don't need the population mean. In order to come up with a confidence interval, we're only concerned with the result of our sample. And your confidence interval, it's the result of your sample plus the margin of error, and the result of your sample minus the margin of error. So I should have X bar minus my margin of error. To calculate the margin of error, it's 1.96 by the standard error. Again, notice I'm using sigma over the square root of n. I'm not using proportion because this is numerical data. It's definitely not categorical data, so it's not proportion. Another giveaway is you've got the standard deviation. If there's a standard deviation, you're using the standard error that has a standard deviation in it. So your X bar is 1,050, your sigma is 390, and your n is 50. So the margin of error, the degree to which the result of this sample could be wrong is it could be off by 108.10248. So you add on the potential error, you subtract the potential error, and you work out your mu, which is the average. If you actually worked out the population mean, there's a 95% chance it would lie within this region. It would lie between 941.90 and 1158.10. So if you looked back at what they gave you here, you didn't actually have to, based on what they asked you to do in this question, but if you look back, they claimed it was 994. Based on my statistics, 994 lies within my region, so I wouldn't be able to say that, I wouldn't be able to dispute this. That could be right. So your final marks for that are going for your confidence interval here. Okay, for question 9, we've got 10 marks, then 15 marks, then 10 marks. The first question, we're given a rectangular box that is holding 15 snooker balls. The radius of each one is referred to as or, and I need to find the volume. The volume of a rectangular box is length by width by height. If there's 5 spheres lying in this dimension, that means that the distance from there to there is 10 or. If there's 3 spheres from here to here, the distance from there to there must be 6 or. And the height of this box, well, obviously it just needs to be high enough to be able to fit in one of these spheres, so the height of the box is 2 or. So the volume would be 10 or by 6 or by 2 or, which is 120 or cubed. It said that or was in centimeters, so it's or cubed centimeters cubed. That's your final answer for the first part. Okay, there was 15 marks going for part 2 here. In part 2, we're introduced to a different configuration. It's still a rectangular box. There's still 15 snooker balls in it, but they're in a different order. I need to figure out, is this more efficient than I got in part 1? In other words, is the volume of this rectangular box smaller than the volume of the rectangular box in part 1? They've given you a hint that the first thing you need to do is find the distance P. So to find the distance P, they've given you a right angle triangle. It's clear from the triangle that the distance from the hypotenuse of the triangle is 4 or. The base of the triangle is 2 or. So if I know 2 sides in a right angle triangle, I can get the third side in terms of or by using Pythagoras. If you use Pythagoras' theorem, you end up with P is equal to 2 root 3 or. So once you know that distance, we can get the length, we can get the width, we can get the height. So clearly we can get the volume of this rectangle. Now my diagram leaves a little bit to be desired, so make sure you look at your own, because it's obviously a lot clearer in the question. The distance, the length of this, if you look at your diagram, it's 11 or. There's 5 spheres and then another radius. So it's the distance from here to here, the length of it is 11 or. The important one is getting this dimension. What is this dimension? If you look at your diagram there, it's clearly, there's a radius at the top, a radius at the bottom, and then the distance P. So that dimension is 2 times the radius plus P. And I've already worked out that P is 2 root 3 or. So that dimension, if I just factorize out my or, the length is 11 or, the width is 2 plus 2 root 3 times or. So that's, I'm running out of space here. That's my length and that's my width. Obviously then I'm trying to find the volume, so I need to multiply that by the height. So the height of this box is the same as the height of the last box. It's just 2 times or. It just needs to be high enough to fit 1 snooker ball. So the volume is the height by the width by the length. That'll give me my volume. Now you can ignore the ors. You don't put them into your calculator, obviously. Or by or is or cubed. 2 by 11 by 2 plus 2 root 3 works out as 120.21 or cubed centimeters cubed. Now be careful here. In part 1, the volume of the rectangular box was 120 or cubed centimeters cubed. This one is 120.21 or cubed centimeters cubed. This one has the volume of this box is bigger than the volume of the previous box, which means that this is a less efficient way of arranging the snooker balls. So you would say that 120.21 is bigger than 120, so therefore this is less efficient. It's a less efficient configuration of the snooker balls. Okay, the final question in this test, there was 10 marks going for question 9, part 3. It says the diagram shows a third configuration in which the snooker balls can be packed. So again, now my diagram, obviously, You've no idea how many times I tried this, so this is as good as we're going to get. There's 15 snooker balls there, so this is another way of organizing the snooker balls. I need to figure out, is this more efficient than the previous two examples? So I need to get the volume of this rectangular box. And obviously the first thing that I want to do is if I can get the area of the triangle, it'll be relatively straightforward to get the volume of the box. Now the easiest way to get the area of this triangle is going to be to use half the base, sorry, not half the base, but the perpendicular height. The easiest way is going to be to use a half AB sine C. The reason that that one is going to be the easiest is because this is an equilateral triangle. I know that each of these three angles is 60 degrees. That angle there, for example, is 60 degrees. So to get the area of this triangle using a half AB sine C, you need to know an angle and there's two sides around it. But clearly, if it's an equilateral triangle, all three sides are the same. So if I can just get the length of one of the sides, I know the angle is 60, I know the length of the side is the same, so it's A and B, they'll both be the same thing. So if I can just find the length of one of the sides of this triangle, I can use this formula to get the area of the triangle. So obviously, let's just consider this one on the bottom. It's relatively straightforward to go from there to there. There's three spheres in the middle, there's half of a sphere there, there's half of a sphere there. So that distance is 8 or. My problem lies in the fact that at the moment, I don't know what that distance is in terms of or. Clearly this distance and that distance will be the same because it's an equilateral triangle. So what I need to do is try and figure out what is this distance in terms of or. And in order to do that, I'm going to come up with a right angle triangle in the little corner. Now let me do that just a little bit bigger. This triangle represents the triangle in the corner. I know the distance from here to here, the distance from there to the middle of this sphere is called or. We originally said that this is an equilateral triangle, which means 60, 60, and 60. I'm splitting this in half, so that means that this angle is 30 degrees. And the distance that I'm trying to find is this distance here. Let's just call it the D for the distance. I know that's 30 degrees, I know the opposite, and I'm looking for the adjacent. If I know opposite and I'm looking for adjacent, clearly we're talking about the tan. I can say that the tan of 30 is equal to the opposite, which is or, over the adjacent, which is D. I want to get D on its own, so I can say that D is equal to or over the tan of 30. Now, if I simplify that down, the tan of 30 works out as 1 over root 3. But dividing by 1 over root 3 is the same as multiplying by root 3 over 1. So I can just multiply by root 3 over 1. Obviously, root 3 over 1 by or is just the square root of 3 or. So the distance, this distance here, can just be written as root 3 or. That's the tricky calculation in this question. Now the rest of it is relatively straightforward. So I've worked out using that right angle triangle that that distance there is root 3 or. Obviously, by extension, that means that this distance here is root 3 or. I said at the very start, the only piece of information I need in order to get the area of this triangle is one of these lengths. I can now say that that length is root 3 plus 8 plus root 3 or. So we could write it out, root 3 or plus root 3 or plus 8 or. I could factorize out my or, and I could add the root 3 and the root 3. So the simplest way of writing that is 2 root 3 plus 8 times or. So once I know one of those lengths, happy days, all three lengths are 2 root 3 plus 8 or. To get the area of this triangle, it's just a half AB sine C, where A is this distance, B is the same distance again, so they're the two sides, then the sine of the angle in between them is the sine of 60. Or by or becomes or squared. A half by that bracket by the sine of 60 is root 3 times 4 plus root 3 to be squared. Now you can write that as a decimal if you want at this stage, that's fine, because my answer makes more sense as a decimal anyway. That's the area of the triangle. But I wasn't asked to find the area, I was asked to find the volume of this rectangular box. So if you know the area of the base of the box, in order to find the volume, you just multiply that by the height. The height of this box will be the same as the height of the other two boxes we dealt with. The height of the box is 2 or. So you take the area of the triangle and you multiply it by the height, which is 2r. So you take that, you multiply it by that. Clearly now, we'll finish this one off up here. So the volume of this box, well, the r by the r squared is obviously going to just give you an r cubed. 2 multiplied by these numbers is going to give you 113.82 r cubed centimeters cubed. So notice now that the volume of this triangular configuration is smaller than the volume of the other two ones. They were both around 120. So this is actually the most efficient way of stacking 15 snooker balls. So I hope that video makes sense. As always, make sure you get on to us, get on to myself, or get on to Jer. If there's anything there you're not 100% on, make sure you're clear on them before you go into your leaving cert next week.